Hello and welcome back to Math with Mrs. Becker. Today in Algebra 2, we are going to complete the last section in Chapter 3. In 3.6, we get to solve systems of linear equations that have three variables. So in 3.5, what happened is we really upped our game. We went from ordered pairs to ordered triples. And we went from coordinate planes to coordinate space. So now in 3.6, when we're looking at systems of equations, get ready because we're upping our game again. A system of three equations with three variables is often called a 3x3 system. What that means is our systems now are going to have to contain three equations. This is why. There's a general rule, and it says to find a single solution to any system of equations, you need as many equations as you have variables. And so just to kind of remind us something that we've already done in this chapter, here is a 2x2 system. This is where we started the chapter. In 3.1, we graphed these, and our solution was the ordered pair where they crossed. In 3.2, we looked at substitution and elimination, and again, our solution was an ordered pair. Now, what they're telling us is because we have two variables, we have x's and y's, that's the reason why we have two equations. Well, now that we upped our game in 3.5 and we have x's, y's, and z's, in order to do this, solving a system using algebra, because we added another variable, we have to add another equation. Okay, so recall from lesson 3.5 that the graph of a linear equation, remember if you had an equation, you had to find the three intercepts and you graphed them and you filled it in to show that it was a three-dimensional object called a plane. And that's what they want you to know here. When you graphed a system of three linear equations in three dimensions, you got planes, okay? Oh, so if I take three equations, what they're telling us is now that we're going to look at a system with three, when you graph three different planes, the results are one of these options. They might never touch it at all. Okay, these are all inconsistent. Remember, inconsistent means that there's no solution. They might have one line cross, but the reason why this is inconsistent is because these three planes don't all meet at the same point. So there is not a single solution that would work for all three. These two cross and these two cross, but there's not a location where all three of them do. Same thing here. Those two cross, those two cross, those two cross, but it's still no solution because there is no location where all three planes meet at the same spot. Okay, so the solution to the set of a system is the set of points where all three planes intersect. This never happens in those three examples. So it's just cool to know that when we're solving this using algebra, if we end up with no solution, what's happening graphically is one of these options. Kind of fun. Okay, this is what it looks like. If you have one solution, you guys, this is what the graph would look like. If we were actually 3D graphing on like isometric dot paper and coloring things in, it would get kind of wild and it's kind of difficult. But if we were to do that, when you have one solution, your solution is x, y, z, always in that order. It's an order triple. And what that means is there's one point in all of those planes where they all have that point in common. So what you found is that one intersection point. Guess what? If I have something like this, notice that they all cross at a line. If they all cross at a line, it's infinite. So again, visually, if you have no solution, if we go ahead and we start solving things and all of the variables cancel and you end up with like 5 equals 2, well, 5 doesn't equal 2. So what that means is that there's no location where all three of those planes meet. If you find a value, if you can solve for x, y, and z, that means that this visually is what's going on. They all intersect at one exact point right in the middle. If you end up with all of your variables canceling and you have like 5 equals 5, well, 5 always equals 5. So what that means is that there's a location where they intersect where it's going to form a line. So you would have an infinite amount of solutions. Okay. So as you can see, identifying the exact solution from a graph would be really difficult. Okay. We are not going to solve by graphing. We're jumping right to algebra. The method of elimination is going to be your best friend. What you want to do is go ahead and take your 3 by 3 system. You want to pick 2 equations, eliminate a variable. Pick 2 different equations and eliminate the same variable. When you do that, what you created is a 2 by 2 system. Then you can go back to the skills that we covered in 3.2 to solve for the 2 remaining variables. Then you can fill those 2 values into one of the originals to solve for the third. That's the process. Let's go for it. Okay, and it does not matter which variable you cancel, okay? So step 1, you pick 2 equations and you cancel a variable. So you're using elimination. Let's say I pick the top and the bottom and I want to cancel z. So that means in front of z, I need a positive and a negative of the same number. Well, this is -3 and this is a +1. So if I multiply the whole second row by 3, I would have opposites in front of z. So on the top, I'm leaving it 5x minus 2y minus 3z equals -7. Now the second equation, I have to multiply everything by 3. 3 times 2x is 6x. 3 times -3y is -9y. 3 times positive z is positive 3z. 3 times -16 is -48. Now you add those together and you want to make sure that you can eliminate a variable. We are eliminating z. 5x plus 6x is 11x. -2y and -9y is -11y. -7 and -48 is -55. Okay, that's step 1. Pick 2 equations, cancel a variable. Now step 2, you pick 2 different equations. So I can pick the top and the bottom, or I can pick the middle and the bottom. But you have to include the bottom because we have not used that yet. I'm going to do the middle and the bottom, okay? So you're picking 2 different equations. You have to cancel the same variable. If I canceled z the first time, again, I have to cancel z. So when I look at just these 2, I'm not worried about this one anymore. When I look at these 2, I need the same number but opposite signs in front of z. This is a -2, this is a +1. If I multiply the whole second row by 2, this would be a +2z. So I'm multiplying the whole top row by 2. 2 times 2z is, 2 times 2x is 4x. 2 times -3y is -6y. 2 times z is 2z. 2 times -16 is -32. Keep the bottom the same because I do have opposites in front of z, and that's what I want. Now when I add those together, 4x and 3x make 7x. -4y and -6y and +4y makes -2y, and the z's cancel. -32 plus 7 is -25. Okay, so just again a recap because it is the same process all the time. Pick 2 equations, cancel a variable. Pick 2 different equations, cancel the same variable. Now what they were telling us on the previous slide is once you have done that, I take those 2 equations and you guys, now I have a 2 by 2. So this is 11x minus 11y equals -55. This is 7x minus 2y equals -25. Now this is a 2 by 2. We solved 2 by 2s in chapter 2, section 2. Okay, so if I'm doing elimination, you have to figure out, all right, what do I want to cancel? Well, let's say I want to cancel y. Well, I need to find a number that both 11 and 2 can be turned into. Well, they both can become 22. I need one positive and one negative. So if I multiply the whole top by -2, -2 times -11 would be +22. So to make this value a -22, I would multiply by 11. Remember, when you do multiply, it has to go across to everything. So -2 times 11x is -22x. -2 times -11 is +22y. -2 times -55 is +110. Now I go ahead, sorry about that, and I multiply everything in the second row by 11. 7x times 11, 77x. 11 times negative 2y, negative 22y. 11 times negative 25 is negative 275. Add those together, we eliminated the y. Negative 22x plus 77x is 55x. 110 minus 275 is negative 165. To solve for x, I need to divide both sides by 55. Negative 165 divided by 55 is negative 3. So I know one variable. You have to find the ordered triple. That means you have to go back and find y and z. When you know one value, you go back to one of the equations that has 2. Okay, so once you know one variable, go to one of the equations that has 2 and fill it in. I'm going to fill it into here. It does not matter which one you fill it into. As long as you do the math correctly, you would get the same answer. So if I go 7 times x is a negative 3 minus 2 times y equals negative 25. Positive 7 times negative 3 is negative 21 minus 2y equals negative 25. If I add 21 to the other side, negative 25 plus 21 is negative 4. Divide both sides by negative 2. Negative divided by a negative is a positive. 4 divided by 2 is 2. So x is negative 3, y is 2. Once you know 2 variables, you go back to one of the originals and fill it in to solve for the third. So let's just go ahead and I'm going to use the top. So 5x, x is a negative 3, minus 2 times y, y is a 2, minus 3z equals negative 7. Well, 5 times negative 3 is negative 15. Negative 2 times 2 is a negative 4, minus 3z equals negative 7. Negative 15 and a negative 4 is negative 19, minus 3z equals negative 7. If I go ahead and I add 19 over negative 7 plus 19, I would have negative 3 left on this side. This side would be a 12. Divide both sides by negative 3. Positive divided by a negative is a negative. 12 divided by 3 is 4. I have x, I have y, I have z. My solution is negative 3 to negative 4. You guys, that's one question. The process is elimination, okay? Again, the big thing is you have to go right in order. So if you like to write down step by step, this is actually a section where you could do that. Step 1, pick 2 equations, eliminate a variable. Step 2, pick 2 different equations, eliminate the same variable. Step 3, take the results from steps 1 and 2 to turn them into a 2-by-2 system. Then you solve that 2-by-2 system using the elimination method from 3.2. Once you find one solution, you fill it back into one of the equations from the 2-by-2. Once you find 2 variables, you fill them back into one of the original that has 3 variables so you can solve for the third. It will always be the same process. Yes, it's lengthy. Yes, you can do it. I promise. Okay, that was just one. Let's go ahead and do another one. Now that time we canceled z. It is important that you realize that you can cancel any variable. It does not matter. You can cancel x's, you can cancel y's, you can cancel z's. So this one, I do realize that I was running out of room, so it's probably a little bit difficult to follow. So I am just going to use a separate sheet of paper as I do the work to try to keep it a little bit more organized for you, okay? This time, just to change it up, let's cancel y, okay? So if I take the top 2 and I want to cancel a y, that means that I need opposites in front of y. This is a positive 3y, so this would need to be a negative 3y. To make that happen, I'd have to multiply everything on the top by negative 3. Every single value. So this would become negative 3 times negative, I'm going to start off right here. Negative 3 times negative x is positive 3x. Negative 3 times y is negative 3y. Negative 3 times 2z is negative 6z. Negative 3 times 7 is negative 21. Keep the second one the same because I'm trying to cancel the y, and I would have opposites if I keep it. 2x plus 3y plus z equals 1. Add them together, a variable should cancel. 3x plus 2x makes 5x. Negative 6z plus 1z is negative 5z. Negative 21 plus 1 is negative 20. So that's step 1. Step 2, I have to use the bottom, and then I could use the bottom with the top or the bottom with the middle. I'm going to go top and bottom. It's important that you cancel the same variable. Because we canceled y the first step, I need to cancel y again. So if I'm looking at the top and the bottom has a negative 4 in front of the y. The top is just a 1. So if I multiply the whole top by negative 4, if I multiply the whole top by positive 4, we would have opposites. Okay, so I'm multiplying the whole top by positive 4. Positive 4 times negative x is negative 4x. Positive 4 times positive y is positive 4y. 4 times 2z is 8z. 4 times 7 is 28. I'm keeping the third row the same. Negative 3x minus 4y plus z equals 4. Add them together. The same variable should cancel, and it did. Our y's, we had opposites in front. Negative 4x and a negative 3x is negative 7x. 8z and 1z makes 9z. 28 plus 4 is 32. Now what we do is we take the result from those two steps and we turn that into a 2 by 2 because now I only have two variables. I have x's and z's, so I only need two equations. 5x minus 5z equals negative 20. Negative 7x plus 9z equals 32. I need to cancel a variable. Let's say I want to cancel x. I need to look and say, what's a number I can turn both 5 and 7 into? Well, that's 35. I need one of them positive and one of them negative. Right now, I already have that. The 5 is positive, the 7 is negative. So what I need to do to turn a 5 into a 35 is I multiply by 7. To turn a negative 7 into negative 35, I need to multiply by 5. But you have to remember that you multiply every single term. 7 times 5x, 35x. 7 times negative 5z, negative 35z. 7 times negative 20, negative 140. Now on the bottom, 5 times negative 7x, negative 35x. 5 times 9z is 45z. 5 times 32 is 160. When I add them together, I just canceled the x. Negative 35z plus 45z is 10z. Negative 140 plus 160 is 20. Divide both sides by 10. 20 divided by 10 is 2. Now that I know one variable, you fill it into one of the equations from the 2 by 2. I'm going to go ahead and take the top. So 5x minus 5 times z, which is really a 2, has to equal negative 20. 5x minus 5 times 2 is 10 equals negative 20. If I add the 10 to the other side, 5x equals negative 20 plus 10 is negative 10. Divide both sides by 5. Negative 10 divided by 5 is a negative 2. Now that I know two variables, you go back and you pick one of the originals. So if I pick, let's pick the middle one. Okay, just to show you that you can pick whatever one you want. If I pick the middle is 2 times x. X is a negative 2. Plus 3y, we don't know y. We know x and z. Y is what we canceled originally, so that's what we're trying to solve now. Plus z. Z is 2. It all has to equal 1. Okay, so I go ahead and calculate. Positive 2 times negative 2 is negative 4. Plus 3y plus 2 equals 1. If I combine those two, negative 4 plus 2 is a negative 2. Plus 3y equals 1. If I add the 2 over, if I had 1, when you add 2, 1 plus 2 is 3, Go ahead and divide both sides by 3 and y equals 1. Your final solution, once you know all 3 variables, you have to write it as an order triple, because what these numbers represent is the location in coordinate space where all of those planes meet. So you would go backwards 2. You would go to the right 1, and you'd go up 2. That's the exact point where all of those planes would meet. So your solution is -2, +1, 2. Now, one thing I hope you're noticing after we've done 2 examples, at no time are you getting decimals or fractions as an answer. Okay, this is the first day you're practicing with this. As you are working on the assignment, if you get decimals or fractions, go back and check your work. Okay, I gave you everything will be integers, meaning you can have negatives, you can have 0, you can have positives, but you cannot have decimals. Okay, the next part. Those 2 examples were examples of where you could find an order triple. You could solve for x, y, and z. Okay, remember when we looked at those visuals at the beginning of the section, there are times where you have infinite solutions because the planes cross to form a line. There are times where you have no solution because those 3 planes never intersect all 3 at the same place. So when that happens, remember we have consistent and inconsistent solutions. So it is possible for all of these variables in this process to cross off. Let's see what happens. Okay, so we're going to go ahead, do the exact same thing that we were just doing. Let's go step 1. I always like to pick the top 2 equations. Not quite sure why. So if I pick the top 2, and let's say I want to cancel x, because in the first example we canceled z, the second example we canceled y. I think it's important that you realize you can cancel any of them. Okay, so let's go ahead and cancel x. If I want opposites in front of an x, I do notice that this is positive, this is negative. That's awesome. I just need these 2 to be the same number. A number I can turn both 2 and 3 into is 6. So I multiply the whole top by 3 and the second row by 2. 3 times 2x, 6x. 3 times -6y, -18y. 3 times 4z, 12z. 3 times 2 is 6. Okay, that's the new top. Now the second equation, multiply everything by 2. 2 times -3x, -6x. Look at that, we got our opposites. Woo! 2 times 9y is 18y. 2 times -6 is -12z. 2 times -3 is -6. Add them together. Cancels. Hey, cancels. Cancels. Everything canceled on this side, so I have a 0. Everything canceled on this side, so it's 0. So now you ask yourself, okay, when does 0 equal 0? Always. So the location where they cross is a line, because a line is infinite. Okay, so here we have infinite solutions, and the reason why is because 0 always equals 0. Infinite solutions, it has a solution, so it's consistent. And you guys, that is 3.6. We are going to work on this process all week, okay? I know this is not something that you're going to pick up the first time and just hammer through it. So your assignment for the first part is 1 to 3, and then jump ahead and do 5 to 10. Okay, don't be afraid to try different things. If you get in the middle and you feel lost, there are times at the beginning of this concept where you might have to start over. But it's important to know that you can cancel any variable, but you have to remember what you cancel in the first step. You have to cancel that same variable in the second step. It is possible for all of your letters to cancel out because there are times where you don't have an x, y, and a z solution. Those are times where you have either no solution or infinite solutions. Okay, so I want you to give this a whirl. I am going to help you when we do our Zoom call, okay? I plan on doing a lot of these with you. So please be brave, dive right into it. I believe in you, you've got this, and I'll talk to you soon.